Welcome to my best guess paper for the 14th of May 2026 Maths Higher Paper 1. All of the questions in this paper have been chosen spotting trends and patterns that have cropped up over the past 5 years of Paper 1 exams. Before I get into the video, if you're new to the channel, please consider subscribing. I'm a private maths tutor with over 7 years of experience and release GCSE Maths videos every day to try and help you improve your grade. Plus, I will always provide a free downloadable PDF in the description that covers the contents in this video. A quick disclaimer, this predicted paper has been carefully created using the past paper exam trends from the 5 most recent GCSE papers. However, they are not affiliated with or endorsed by any exam board. While it has been designed to be highly representative, there is no guarantee that the actual exam will contain the same questions or topics. Question 1. This question says the first two terms of a geometric progression are 4 over 9 and 8 over 27. Circle the third term. So what is a geometric progression? A geometric progression is a sequence where we multiply or divide to get the next consecutive term. So we need to think, what do we need to multiply 4 over 9 by to give us 8 over 27? So to do this sum, we're going to do 8 over 27 divided by 4 over 9. So when we're dividing fractions, we need to think of keep, change, and then flip. So 8 times 9 is 72, and then 27 times 4 is equal to 108. We can divide the top and the bottom of this fraction by 9 to give us 8 over 12, and then we can simplify this dividing top and bottom by 4 to give us 2 over 3. So it's going up in multiples of 2 over 3, so we need to times 8 over 27 by 2 over 3, and to multiply fractions we just multiply straight across the top and straight across the bottom. So 8 times 2 is 16, and then 27 times 3 is equal to 81. So the answer that we're going to circle in this list is 16 over 81. Question 2 says write a number in each box to make the calculations correct. So we've got 12 divided by minus 3 multiplied by something equals 40. So 12 divided by minus 3, this is equal to minus 4. And then minus 4 times something is equal to 40. So minus 4 times minus 10 gives us 40. The next one looks at 0.6 times something, let's call that x, times 22 is equal to 66. So first let's multiply 0.6 by 22. So to do this, I'm going to just do 22 multiplied by 6. So 6 times 2 is 12, carry the 1. 6 times 2 is 12, add the 1, which is 13. So we've got 132. We've moved the decimal point 1 unit to the right, so we're going to move the decimal point from the end 1 unit to the left to give us 13.2. So we've got 13.2 multiplied by x, and this is equal to 66. So to get x on its own, I'm going to divide both sides of the equation by 13.2, so 66 divided by 13.2. So to do this, I'm going to use the bus stop method. I'm going to do 66 divided by 132 and then put the decimal point back in. So how many 132s go into 6? That's 0, carry the 6. That's also going to be 0, carry 660. And there's 5 132s that go into 660. And then we're going to stick the 0 on the end. And then we've moved the decimal point 1 unit to the right. So we're going to move the decimal point 1 unit to the left from the end in this bus stop method to give us 5. So 0.6 times 5 times 22 is equal to 66. Question 3 says write these numbers in order of size, starting with the smallest number. So if we turn all of these numbers into decimals, 5 to the power of minus 1 is 1 over 5. So whenever we've got a negative power, we always do 1 over the base number, which is 5, raised to the positive power, which is 1, and 5 to the power of 1 is just 5. So 1 over 5 is equal to 0.2. We've got 0.5, we've got minus 5, and then anything to the power of 0 is always 1. So starting with the smallest number is minus 5, and then 0.2, and then 0.5, and then 1. So writing these out how they originally looked, we've got -5, and then 0.2 is 5 to the power of -1, and then 0.5 is just 0.5, and then 1 is 5 to the power of 0. So this is the final list. Question 4 says work out 54.6 times 4.3. So to do this question, it's just decimal arithmetic. So we're going to do 546 times 43. So we're going to take the decimal points out and then put them back in. So we've moved the decimal point 1 unit to the right here, and we've moved the decimal point 1 unit to the right here. So to do this question, I'm going to draw the grid method. So we've got 546 times 43. So 5 times 4 is 20, and I'm going to stick 3 zeros on the end. 4 times 4 is 16, stick the 2 zeros on the end. 4 times 6 is 24, stick the 0 on the end. 3 times 5 is 15, stick the 2 zeros on the end. 3 times 4 is 12, stick the 0 on the end. And 3 times 6 is 18. So we're going to add all of these numbers up in the middle. So we've got 20,000 plus 1,600 plus 1,500 plus 120 plus 240 plus 18. So adding these up, on the end we've got 8. 4 plus 2 is 6 plus 1 is 7. 6 plus 2 is 8. 8 plus 1 is 9, and 9 plus 5 is 14. And then we've got 1, 2, 3, and then a 2 on the end. So in total, we've moved the decimal points 2 units to the right up at the top. So we're going to move the decimal point from the end 2 units to the left. So 1, 2. So the final answer will be 234.78. Question 5 says work out 8.5 divided by 2 2/3. So to do this calculation, we're going to multiply 8 by the 2 and then add the 1 to turn this into an improper fraction. So 8 times 2 is 16 plus 1 is 17 over the original denominator of 2, divided by 2 times 3, which is 6, add 2 is 8 over the original denominator 3. To divide fractions, we keep the first fraction, change the sign to a multiplication sign, and then flip the final fraction. So 17 multiplied by 3. 7 times 3 is 21. 3 times 1 is 3. Add 2 is 5. So this answer is 51, and this is divided by 16. Then we think, how many 16s fit into 51? So there's 3 16s that fit into 51, because 3 times 16 is 48. And then therefore there's 3 remaining over the original denominator of 16. So the final answer is 3 3/16. Question 6 says Jim rounds a number x to 1 decimal place. The result is 7.2. Write down the error interval for x. So when we're looking at error intervals, we have these inequalities, and either side we need to fill in what these numbers are. So the margin of error is 1 decimal place. So to get the tolerance, we divide 1 decimal place, which looks like this. So using zeros and ones, and then we divide this by 2 to give us 0.05. So we've got this plus or minus value that we can add or subtract to 7.2 to give us the upper bound and the lower bound. So to get the upper bound, we're going to add 0.05 to 7.2 to give us 7.25. And to get the lower bound, we're going to do 7.2 subtract 0.05 to give us 7.15. Question 7. Complete the Venn diagram to represent this information. So we've got the set that includes odd numbers less than 30. We've got A that includes 3, 9, 15, 21 and 27. And B includes 5, 15, 25. So if we look at all of the odd numbers less than 30, we've got 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, and 29. So in the middle, this includes the values that are in both A and B. So 15 is included in both. In A, we've got 3, 9, 21 and 27. And in B, we've got 5 and 25. So let's have a look what is not included. So we've got a 3 in A, so that's already been used. A 5 is already been used. 7 hasn't. A 9 is already been used. 11 hasn't. 13 hasn't. 15's already been used. 17 hasn't. 19 hasn't. 21 is already been used. 23 hasn't. 25 has been used. 27 has been used, and 29 hasn't. So around the outside, we're going to have 1, 7, 11, 13, 17, 19, 23, and 29. So that is the completed Venn diagram. Now part B says a number is chosen at random from the universal set. What is the probability that the number is in the set A union B? So this symbol here means or, so either A or B. So the shaded region that represents that probability is everything within the Venn diagram. So how many numbers are within the Venn diagram? We've got 1, 2, 3, 4, 5, 6, 7. We've got 7 out of a total possible 8, 9, 10, 11, 12, 13, 14, 15. So the final answer is 7 over 15. Question 8 says circle the vector that translates the point -2, 7 to the point 3, -1. So if we draw an axis to represent this information, we've got the x-axis and the y-axis. So labeling the point -2, 7, that's probably somewhere up here. And then we've got the point 3, -1, so that's somewhere about here. So we need to think how many units do we go along and how many units do we go down by. So we've gone from -2 to 3, so that's gone along by 5, and we've gone from 7 to -1, so we've gone down by 8, so that's going to be -8. So the top unit in column vectors represents the x translation, and the bottom number represents the y translation. So we've got 5 -8, so this is the one we're going to circle. Question 9 says use algebra to show that the recurring decimal 0.2545454 and so on is equal to 14 over 55. So the method to do this is to say let x equal the decimal, so 0.2545454 and so on. Then we say let 10x equal 2.54545454 and so on. And then we say let 100x equal 25.45454544 and so on. And each time we're trying to get a match to the right hand side of the decimal point. So currently this one starts with a 2, this one starts with a 5, and this one starts with a 4. So we haven't got a match yet, so we need to keep going in multiples of 10 on the left hand side. So we're going to look at 1000x next. And this is equal to 254.54545454 and so on. And this is line 1, this is line 2, this is line 3, and this is line 4. And you can see here that we've got a match to the right hand side of the decimal point with lines 4 and lines 2. So if we do 1000x, subtract 10x, so we're going to subtract line 2 away from line 4. This means that the decimal point will cancel out, so we're just left with 254 subtract 2 on the right hand side of the equal sign. 1000x minus 10x is equal to 990x, and this is equal to 252. So if we divide both sides of the equation by 990, we're going to get 252 divided by 990. So we need to show that it's equal to 14 over 55. So you can work out what this factor is that we're dividing the top and bottom by. If we do 252 divided by 14, so how many 14s go into 2? That's 0, carry the 2. How many 14s go into 25? That's 1, and we're going to carry 25 subtract 14, which is equal to 11. And then we need to think how many 14s go into 112. So we can do the bus stop again. So this is 0, carry the 1. This is 0, carry the 11. And then how many 14s go into 112? So if we do 14 times 8, 4 times 8 is equal to 32. 8 times 1 is 8, plus the 3 is equal to 11. So the answer that we're dividing the top and bottom by is 18. So 252 divided by 18 is 14, and 990 divided by 18 is 55. So we've shown that that recurring decimal is equal to 14 over 55. Question 10 says there are some people in a cinema. 3/5 of the people in the cinema are children. For the children in the cinema, the number of girls to the number of boys is 2 to 7. There are 170 girls in the cinema. Work out the number of adults in the cinema. So you've got the number of girls to the number of boys is 2 to 7. So we're going to do the block method for this. We know that there are 170 girls in the cinema. So 170 divided by 2. So 100 divided by 2 is 50. 70 divided by 2 is 35. Add these together, this is 85. So each block is worth 85 in this ratio. We can find out what the total is by doing 85 multiplied by 7. So 7 times 5 is 35. 7 times 8 is 56. Add 3 is equal to 59. So we can work out the total number of children in the cinema if we do 595 plus 170. So 5 plus 0 is 5. 9 plus 7 is 16. Carry the 1. And then 5 plus 2 is 7. So the total number of children in the cinema is 765. We know that 3/5 of the people in the cinema are children. So 3/5 of the total, which we'll call x, is equal to 765. So 3x over 5 is equal to 765. If we do 765 times 5, that is equal to 3,825. And then if we divide 3,825 by 3, we get 1,275. So that is equal to the value for x, which is the total number of people in the cinema. And if there's 3/5 of the people in the cinema that are children, then that means that 2/5 of the people in the cinema will be adults. So 2/5 times 1,275. So if we do 1,275 divided by 5, that's going to be 0. Carry the 1. How many 5s go into 12? That's 2. Carry the 2. How many 5s go into 27? That's 5, with a remainder of 2. And how many 5s go into 25? That is 5. So we've got 255, and we need to multiply this value by 2. And when we do that, we're going to get 10, carry the 1, 11, carry the 1, and then 5. So the final answer is 510 adults. Question 11 says calculate the value of x. Give your answer correct to 3 significant figures. So this is the opposite, this is the hypotenuse, and this is the adjacent. So we're going to use SOHCAHTOA to find out what x is, and we also have to note what our exact trig values are. So SOHCAHTOA, we've been given h, and we need to find o, which is x. So that corresponds to SOH. So this is sine followed by the angle, which is 60, is equal to O, which is x, over h, which is 32. So to get x on its own, multiply both sides of the equation by 32 to give us 32 times sine of 60. So we can use the hand to find our exact trig values. So this is 0 degrees, this is 30 degrees, this is 45, this is 60, and this is 90. So locate first the 60-degree finger, which is this one here. For sine, we count how many fingers are below this finger here, and this is for sine. So we've got 3 fingers below, so we've got the square root number of fingers, which is 3 divided by 2. So sine of 60 is root 3 over 2. So we can do 32 multiplied by root 3 over 2, which is equal to 32 root 3 over 2, which is equal to 16 root 3. So that is the final answer. Question 12 says 3 kilograms of potatoes and 4 kilograms of carrots have a total cost of 440 pence. 4 kilograms of potatoes and 3 kilograms of carrots have a total cost of 470 pence. Work out the total cost of 1 kilogram of potatoes and 1 kilogram of carrots. So this is a simultaneous equation in disguise. So we can say 3p plus 4c is equal to 440 pence. And then 4p plus 3c is equal to 470. So we can solve simultaneous equations by either making the p values the same or the c values the same in this context. So if we multiply the top equation by 4 and the bottom equation by 3, then we'll get 12p for both. On the top we'll get 4 times 4, which is 16c, and 4 times 440. This is equal to 1760. And then for the bottom, 3 times 3c is 9c, and then 470 times 3 is equal to 1410. So signs the same, subtract, signs different, add. The signs for the values that we've made the same, in this case the 12p's, they are both positive, so the signs are the same, so we're going to subtract the equations. So we get 0 here, 16 subtract 9 is equal to 7c, and then 1760 subtract 1410 is equal to 350, and then if we do 350 divided by 7 to get c on its own, c is equal to 50. Now to get the value for p, we substitute c either into equation 1 or equation 2. So let's use equation 1. 3p plus 4 times 50 is equal to 440. 3p plus 200 is equal to 440. And then if we subtract 200 from both sides, we get 240. And then if we divide both sides of the equation by 3, we get p, which is equal to 80. So the total cost will be 80 pence plus 50 pence, which is equal to 130 pence, which is equal to £1.30. So that is the final answer for question 12. Question 13 says, n is greater than minus 2 but less than or equal to 3. Represent this inequality on the number line. So we've got a strict inequality next to the minus 2, which means we've got an open circle at minus 2. And then we've got an inclusive inequality next to the 3, so that means we fill in the circle at 3. And then we join these 2 points up with a line. Part B says solve the inequality 8x minus 3 is greater than or equal to 6x plus 4. So we need all of the algebra on the left hand side and all of the numbers on the right. So the first thing that we're going to do is subtract 6x from both sides of the equation to give us 2x minus 3 is greater than or equal to 4. Next, we're going to add 3 to both sides to get the numbers on the right hand side to give us 2x is greater than or equal to 7. And finally, to get x on its own, we can divide both sides of the equation by 2 to give us x is greater than or equal to 7 over 2. So that is the final answer for part B. Question 14 says some students were asked how many times each week they used their mobile phones last week. The box plot gives information about the male students' answers and about the female students' answers. Compare the two distributions represented by the box plots. So when we're comparing distributions according to box plots, we need to compare the median and the interquartile range. So the median is represented by this section here, and the interquartile range is the upper quartile subtract the lower quartile. So we can say that the average mobile phone usage was the same for both the males and the females. And then in brackets, I'm just going to put 40 times. The second point that we can note is that the interquartile range for the females is greater than the interquartile range for the males. So you can say the females had a greater spread for mobile phone usage compared to the males. So they are the 2 points that we need to record when we're asked to compare distributions with box plots. Question 15 says A, B and C are points on the circle. X squared plus y squared is equal to 36 as shown. A is on the y-axis and B is on the x-axis. M is the midpoint of AB. Part A says show that the coordinates A are 0, 6. So this point here lies on the circle and it has an x coordinate of 0. We've got the equation of the circle, which is x squared plus y squared equals 36. So if we substitute in 0 into this equation, we should get 6 for the y coordinate. So x squared plus y squared equals 36. So 0 squared plus y squared is equal to 36. Therefore, 0 squared is just 0, so we get y squared equals 36. And if we square root both sides of the equation, y is equal to 6. Part B says work out the coordinates of B. So the opposite is happening here, where the y coordinate is 0. So if we substitute in 0 for where we see y, we've got x squared plus 0 squared equals 36. Therefore, x squared equals 36. So x is equal to 6, square rooting both sides. And we know that the equation of a circle is x squared plus y squared equals r squared. So r squared is equal to 36. So the radius is equal to 6. So this section here is 6. And also this section here is 6. So you could also write that down. Part C says show that the equation of the straight line passing through COM is equal to y equals x. So the equation of a straight line is y equals mx plus c. So to find out the gradient, we need a point on the line. So that is m. M is the midpoint. The equation or formula for finding the midpoint is x1 plus x2 all over 2, and then y1 plus y2 all over 2. So if we've got this coordinate here, which is at 0, 6, and this coordinate here, which is at 6, 0, then that means we get x1, which is 0, plus x2, which is 6, so 6 over 2, and then y1, which is 6, and then y2, which is 0, so again it's just 6 over 2. So this is equal to 3, 3. So m is at 3, 3. So the gradient is the rise over the run. So it's gone up by 3 and along by 3. So 3 divided by 3 is 1. So that means m is 1. So we just get y equals x. And then the plus c value is the y-intercept of this line. And you can see that it crosses the point at 0, 0. So the final answer will be y equals x. Question 16 says write down the value of 10 to the power of 0. So anything to the power of 0 is always 1. Part B says write 6.7 times 10 to the power of minus 5 as an ordinary number. So if we've got 6.7, the minus 5 signifies that we move the decimal point 5 units to the left. So 1, 2, 3, 4, 5. And then we fill in the gaps with zeros. So the final answer will be 0.000067. Part C says work out the value of 3 times 10 to the power of 7 times 9 times 10 to the power of 6. So if we do the numbers first, 3 times 9 is equal to 27, and then 10 to the power of 7 times 10 to the power of 6. When we've got the same bases separated by a multiplication sign, we add the powers. So this is going to become 10 to the power of 13. With standard form, we need the first number between 1 and 10. So we need to change this to 2.7 times 10 to the power of, and when we decrease this number by a factor of 10, we increase the power by 1. so it becomes 10 to the power of 14. So that is the final answer for part C. Question 17 says write 16 times 8 to the power of 2x as a power of 2 in terms of x. So writing 16 as a power of 2, this is 2 to the power of 4, multiplied by 8 can be written as 2 cubed, and this is all raised to the power of 2x. So if we simplify, when we've got powers next to each other separated by a bracket, we can multiply them together. So this becomes 2 to the power of 6x. And again, same basis, separated by a multiplication sign so we can add the powers. So the final answer will be 2 to the power of 6x plus 4. Question 18 says ABCD is a quadrilateral. Prove that ABCD is not a cyclic quadrilateral. So the important fact to note about cyclic quadrilaterals is that opposite angles sum to 180 degrees. So if we do 5x plus 30 and then we add x plus 36, this should equal 180 degrees. 5x plus x is 6x, 30 plus 36 is 66, and this is equal to 180. So if we do 180 subtract 66, this is equal to 114. And then if we divide both sides of the equation by 6, 114 divided by 6 is equal to 19. So if we substitute this back into this section here, which is 4x, that means 4 times 19 plus 92, this should equal 180. Well, 4 times 19, if we do that, 9 times 4 is 36, 4 times 1 is 4, add 3 is 7, so this becomes 76 plus 92, and this does not equal 180. So therefore, opposite angles in a cyclic quadrilateral don't sum to 180 degrees. Question 19 says work out the values of a and b in this identity. So we've got 5 multiplied by 7x plus 8 plus 3 multiplied by 2x plus b, and this is identical to ax plus 13. So if we multiply out the brackets, 5 times 7x is 35x, and 5 times 8 is 40. 3 times 2x is 6x, and 3 times b is 3b. And this is identical to ax plus 13. So you can see that the 35x section plus 6x section is equal to the ax section on the right hand side. So 35x plus 6x is equal to 41x. And then we've got this plus 40 plus 3b. So this section correlates to this section, so we can compare coefficients. So a is equal to 41, and we've got the other part, which is 40 plus 3b, that correlates to 13. So 40 plus 3b is equal to 13, so we can solve for b. So if we subtract 40 from both sides of the equation, we get minus 27. And then if we divide both sides of the equation by 3, b is equal to minus 9. So the answer for b is minus 9. So those are the two values for question 19. Question 20 says the expression x squared minus 8x plus 21 can be written in the form x minus a all squared plus b for all values of x. Find the values of a and b. So this is completing the square. So to complete the square, we draw our bracket with a squared term outside, and then we have our variable that we're considering in the question, which is x. We half the value in the middle, so half of minus 8 is minus 4, and then we subtract the square of the number inside of the brackets, and then we add the end term, which is 21. So simplifying this, we get x minus 4 all squared, and then minus 16 plus 21. So simplifying this, we get x minus 4 all squared plus 5. So the value for a is minus 4, and the value for b is 5. Part B says the equation of the curve is y equals f of x, where f of x is equal to the quadratic we had previously. The diagram shows part of a sketch of the graph y equals f of x. The minimum point of the curve is m. Write down the coordinates of m. So the important information about completing the square is we can extract the turning point, or also known as the minimum point in this question, from the completing the square form. So we change the sign of the number inside of the brackets, and that becomes our x coordinate, and we keep the number outside and its sign. So the final answer is 4, 5. Question 21 says, here is a speed time graph for a train. Work out an estimate for the distance of the train travelled in the first 20 seconds. Use 4 strips of equal width. So if we draw a line at 20, and then we draw a line at 15, and then 10 and 5, we've got 1, 2, 3, 4 equal width strips. And then we can join the points up to form triangles and trapeziums. And then we can work out the area underneath the curve to work out what the distance is. So the distance is the area underneath the graph for a speed time graph. So looking at the area of 1, we've got a triangle, so that's base times height divided by 2. So the base is 5, the height is 0.5, 1, 1.5, 2, and then we divide this by 2, so 5 times 2 is 10, divided by 2 gives us 5, and this is in meters. The area of 2 is a trapezium, so the area of a trapezium is a half a plus b times height. So you've got a half, the a number is this number here, so that is 2, plus b, which is the base number, which is 5, times the height, which is 5. So 2 plus 5 is 7, times 5 is 35, divided by 2. So 34 divided by 2 is 17, and then you've got the 0.5 on the end. Now we've got the area of 2 is also a trapezium. So you've got a half multiplied by 5 plus 10 times 5. So 5 plus 10 is 15. 15 times 5, 25, carry the 2. 5 times 1 is 5, plus 2 is 7. So we've got 75 divided by 2, and 75 divided by 2. So if we do 74 divided by 2, 70 divided by 2 is 35, plus 2 is 37, and then stick the 0.5 on the end, so 37.5 meters. And then we've got the area for number 4. So we've got a half a plus b times height, so half times 10 plus the value in the middle, so it should really extend up to there, which is going to be 18, and then times 5, which is the height. So 18 plus 10 is 28. 28 times 5, so this is 40. 5 times 2 is 10, plus 4 is 140. So we've got 140 divided by 2, which is 70 meters. So we need to now add 5, 17.5, 37.5, and 70 together. So if we do that using column addition, 70, 37.5, 17.5, and then 5. So this is 10, carry the 1. 7 plus 7 is 14. 14 plus 5 is 19. 19 plus 1 is 20. And then we've got 7 plus 3, which is 10, plus 1, 11, plus 2, which is 13. So the total area, or the total distance, is 130 meters. Question 22 says find the nth term of this sequence. So first we find out what the jumps are going up in. So the difference between 6 and 11, this is equal to 5. And then the difference between 11 and 22, this is equal to 11. The difference between 39 and 22 is essentially 8 plus 9, which is equal to 17. Then 62 subtract 39. So we can have there 9 to 12 is equal to 3, and then 5 subtract 3 is 2, so we get 23. And then the difference between 91 and 62 is 29. So the jumps between these values here in the second sequence is plus 6, And a quadratic sequence for the nth term is an squared plus bn plus c, where a is equal, so to get a we can say 2a is equal to the first term of the last sequence, 3a plus b is equal to the first term in the second sequence, and a plus b plus c is equal to the first term in the first sequence. So 2a is equal to 6, so we know that a is equal to 3. 3a plus b is equal to 5. We know that a is 3, so 3 times 3 plus b equals 5. So 9 plus b equals 5. So b is equal to minus 4. And we know that a plus b plus c is equal to 6, where a is 3, b is minus 4, and then we've got plus c equals 6. So 3 minus 4 is equal to minus 1, plus c equals 6. So c is equal to 7. So the final answer, putting all of these together, is 3n squared minus 4n plus 7. Question 23 says, show that 2 root 6 over root 5 minus root 3 over root 10 can be written in the form c root d all over 10. So 2 root 6 over root 5 minus root 3 over root 10. So we need a common denominator to subtract fractions. So to get a common denominator, we can multiply these two surds together to give us root 50. And then we could do cross multiplication to get the numerators. So root 10 times 2 root 6 is equal to 2 root 60. And then root 5 times root 3 is root 15. Before we go any further, we can simplify these surds. Root 60 can be split off into root 4. So if we divide 60 by 4, how many 4 is going to 6? That is 1, carry the 2, and then 5. So root 4, root 15, which simplifies to give us 2 root 15. So we can write this first one as 2 times 2 root 15 over root 50. Root 50 can be simplified and split off into root 25 times root 2, which is 5 root 2. So 5 root 2 on the base. 2 times 2 is 4 root 15 over 5 root 2 minus root 15 over 5 root 2. 4 lots of root 15 minus 1 lot of root 15 is 3 lots of root 15 over 5 root 2. We need to rationalize this denominator, so we times the top and bottom of the fraction by root 2 to give us 3 root 30 over root 2 times root 2 is 2 times 5 is 10. So the final answer is 3 root 30 over 10, and that matches what we expect to see for the denominator at the start of the question. The final question is question 24, and this is a vector proof question. So OA is equal to 5A, OB is equal to 3B, C is the point that OC to CA is 4 to 1, M is the midpoint of AB, D is a point such that OB to OD is 3 to 4. Show that C, M and D are on the same straight line. So if we go from the start, we've got OA, which is 5A, that's marked on the diagram. OB is 3B, that's marked on the diagram. C is a point such that OC to CA is 4 to 1. So that means that C will probably be somewhere up there. We know that this section, which is OC, as a fraction of OA, is 4/5 of OA. And we know that this section here is 1/5 of OA. So that is dealt with that ratio. M is the midpoint of AB, so we know that this section here is half of AB, and we know that this section here is also half of AB. So that's dealt with that section, and then D is a point such that OB to OD is 3 to 4. So from that piece of information there, we can say that the line OD is 4/3 bigger than the line OB. So we can say that OD is equal to 4/3 times OB. So from that ratio, the factor to get us from 3 to 4 is 4 over 3. So we times 3 by 4 over 3 to give us 4. So that means that OD is 4/3 bigger than OB. So to prove that these 3 points here are on a straight line, there is a common phrase that we need to remember. We need to say that the first 2 points, or the vector between the first 2 points, so the vector CM must be a scalar multiple of the total vector, so from C to D. And if we prove that, then we've pretty much done the question. So if we first work out the vector CM, so how do we get from C to M? So to get from C to M, we can go C to A, and then we can add A to M. So this is equal to 1/5 of OA plus half of AB. So 1/5 of OA is 5A, and then plus a half of AB. So AB is from A to B, so minus 5A plus 3B. So 5A times 1/5 is just A, and then a half times minus 5A is minus 5 over 2A, and then a half times 3B is plus 3 over 2B. So 1 minus 5 over 2, this is equal to minus 3 over 2A, and then we've got this plus 3 over 2B. So we can take a factor of 3 over 2 out to the front and inside get minus A plus B, and you'll see why I would do this in the next step. So the next thing we need to work out is CD. So to get from C to D, all we're going to do is go to CO, and then we're going to add O to B, and then we're going to add B to D. So C to O is 4/5 of OA, so OA is 5A, so it's going to be 4/5 of 5A. OB is 3B, and then BD, so we know that OD is equal to 4/3 of OB. We know that OB is 3B, so you can write this as 4/3 times 3B. 3 times 4 is 12. 12 divided by 3 is 4. So we get 4B, which is the length of O to D. OB is 3B, so that means that this part must be 1B to give us that 4B length or vector. So BD is plus B. So if we do 4/5 of 5A, that equals 20A divided by 5, which is 4A. And we have to remember that the 4/5 of OA is going in this direction, but we're going in the other direction, so this needs to be minus. So we're going to get minus 4A, and then 3B plus B is equal to 4B. We can take a factor of 4 out to the front and inside get minus A plus B. So we can see here that we've got a scalar multiple, which is this minus A plus B of both of the vectors, so therefore they must be on a straight line. So the final concluding point is that CM and CD are both scalar multiples of minus A plus B, and they both pass through C. So that section there is the concluding point. This concludes the video on the best guess paper for 14th of May 2026 Maths Higher Paper 1.